Module 10, Searching by Chemical Substance. If you followed the SciFinder tutorial through Module 9, you'll now be familiar with searching for journal articles, books, and patents that are relevant to a specific topic. But many times you'll find that searching by keyword is insufficient for your assignment. For example, in organic chemistry, you'll learn that tetrabutyl ammonium iodide is used as a catalyst in SN2 reactions. Your assignment may be to provide 4 recent examples from the primary literature where it was used for this purpose and to design an experiment to demonstrate its role in the reaction. Unfortunately, journal articles are rarely written about just one chemical compound, so exploring by topic or reference won't turn up anything relevant. You'd have much better luck if you could search by the chemical itself and come up with a set of articles that use it in their experimental section. This effective searching strategy will be covered in the next 2 modules. The current module, Module 10, will demonstrate how to search by substance identifiers and how to find their commercial availability. Module 11 will teach you how to use the drawing editor to search by chemical structure and Marcouche structure. On the main SciFinder webpage, we'll focus on the Substances heading on the left-hand toolbar. There are 5 ways to explore substances: by drawing the chemical structure, performing a Marcouche search, using the molecular formula, entering a property such as a boiling point or melting point, or by entering a substance identifier. We'll focus on the last option. A chemical substance can be identified by either its name or its CAS registry number. To search by name, you can enter the IUPAC name, generic name, trade name, or even an abbreviation. You can alternatively search by its CAS, or Chemical Abstracts, registry number. Almost every chemical compound that has ever been used or synthesized has been assigned a unique identifying CAS number. For our purpose, let's search by name. Type tetrabutyl ammonium iodide in the box and click the search button. One substance is found with its CAS registry number, molecular structure, and alternative identifying names. There are also icons linking to references, reactions, and commercial sources, and below the structure there are links to regulatory information and even spectral and experimental properties. On the left-hand side, there are the familiar Analysis and Refinement tabs, which allow you to further tailor your references to your own needs. Click on the CAS registry number and scroll down to see what type of information is available for TBI. You get references for the chemical properties of TBI, the electrical properties of TBI, its flow and diffusion properties, its enthalpy, entropy, and melting point. And what happens if we expand the experimental spectra link? We find original research articles that report TBI's NMR, IR, and mass spec data? If it's available, it's here. And whoa, hold on a second. What's this? No way. SciFinder even gives a hyperlink to an actual spectrum? Crazy. Then there's regulatory information, and finally, under CAS reference roles, you can click on a role to find all of the references that describe TBI's use in that capacity. Remember, at any time, if you want to return to the original substance identifier window, just click your browser's back button. But we can continue from here for our assignment. Since part of your assignment is to design an experiment, you will need to order all of your chemicals, including TBI, from a commercial vendor. Click on Commercial Sources to view all the vendors that sell TBI. Scroll down to Aldrich, the company from which the Rider University Chemistry Department purchases most of its chemicals. When you click on Aldrich, you'll find its catalog number for TBI, as well as the specific quantities it sells. You could give this information to your professor, who would then be able to purchase the chemical for you. Return to the original query response by clicking the Substances hyperlink, or push your browser's back arrow twice. The assignment also requires that you find 4 recent examples in the literature where TBI was used as a catalyst in a nucleophilic substitution reaction. When you click on the Get Reactions icon, you are asked to classify the role of the chemical in the reaction. Click on the Catalyst radio button and select Get. Over 470,000 reactions appear that have used T-by as a catalyst. To initially focus the list, use the tools you learned in previous modules to refine by the number of steps. First, we're only looking for a one-step SN2 reaction, so let's refine our reactions to one-steppers. The list is now cut to just over 20,000 reactions. But you probably only want to use procedures that have a good yield. You can further refine your references by inputting 80% as the minimum respectable yield. And now we have a list of just over 5,400 reactions. The reactions are listed in order of accession number, but we can easily sort by publication date. Each entry shows the reaction. The molecules to the left of the arrow are reactants, to the right are products, and those under steps and stages are the reaction conditions. R is for reagent, S is for solvent, and C is for catalyst. Each reaction is followed by the title of the reference, its partial bibliographic information, and a link to the full text. If you click on the title, you'll be taken to the reference detail page. At this point, you can read the abstract and decide if you're interested in obtaining the article, and can click the Get Full Text link to see if you can access it at Rider or through interlibrary loan. If you are unfamiliar with these concepts, return to Modules 6 and 7. You have reached the end of Module 10 and should now be adept at searching for reactions by chemical name or CAS number. Continue on to Module 11 to learn how to search by the chemical structure of a molecule.